Hi guys, it's Berg again. This is now lesson 7-7. I'm just going to tell you right now, the way the book is trying to teach you, I think is very, very confusing. So I'm going to be doing my own kind of thing. The only thing that you need to know is that you cannot multiply mixed numbers. You can do it, but it is extremely difficult to do because there are so many different things you have to multiply, and I'll go over that later. But the fastest way to solve this problem is just to change uh, a mixed number and so that will more lives a lot easier. And I'll go over the notes of where it says to do this. So I'm going to flip this around. And in your notes, it did say converting a mixed number to an improper fraction. Now, how you do this, say it was 3 1/5. This happens every single time. What you are going to be doing is you're going to be taking the denominator and timesing it by the whole number. So that would be 5 times 3, which is 15. And then you add whatever your numerator is. So 15 plus 1 is 16. And then you always put it over your original denominator, which is 5. So I'm going to add to your notes here, and I'm going to tell you exactly what to do. So in this case, you would take the denominator and times it by the whole number. So you're going to do that first, then add the numerator. Oh. And then you're just going to put it over the original denominator. So this is how you change a mixed number into an improper fraction. So again, here's another example. It was 2 1/2. You're going to take your denominator, which is what we said. Take your denominator, which is 2, times it by the whole number, which is 2. So 2 times 2 is 4. Then add your numerator. So 4 plus 1 is 5 over the original denominator, which is just slide it over, it's a 2. So this is going to help you a whole lot today. It is so much easier just to change these to mixed numbers rather than doing the other method to multiply mixed numbers, which is very difficult. And people mess up all the time. So I'm trying to tell you, this is the easier way. Whenever you have a mixed number, just change it to an improper fraction when you are multiplying them. All right, so here is what I'm about ready to talk to you about. So it says you can use square tiles with the side lengths that are unit fractions to find the area of a rectangle. Lee wants to cover the rectangular floor of her closet with tile. The floor is 2.5 feet by 3.5 feet. She wants to use the fewest tiles possible. If she doesn't want to cut any of the tiles come in 3 sizes. You could have 1 foot by 1 foot, a 1.5 foot by a half foot, or a 1/4 of a foot by 1/4 of a foot. Choose the tile that Lee should use. What is the area of the closet? Okay, so if you were doing this, could you use 1 tiles if you have 1 whole tiles if you don't want to cut it to show 2.5 feet or 3.5 feet? The answer is no, you cannot. It said that you need a half. Well, in order to get a half of this, you would have to cut it in half. So therefore, this is not a good tile to use. How about if you had a half foot by a half foot? Well, could you now do that? Well, this is going by halves and this one is going by halves. So this would be a good one to use because there are halves that you could use. Here, you could use this because it is just, that just means you just cut this one. That would be like this. Yes, you could, but it said it wants to use the fewest tiles possible. So in order to do this, you would have to use this one. But they already wanted you to know that, which I don't agree with on this. So we would be using the half foot by the half foot. So the biggest thing that I want you to know is, see, we would be using the half by a half foot because that one would work better. But I do want you to write something down here. It says when multiplying mixed numbers, the fastest way is to solve the problem is to change a mixed number to improper fractions. So I'm going to give you some other examples, just a quick example again. So yes, we're going based off of what our notes said, but you could also write it up here. Again, if the problem was, we'll use different numbers here, 1 2/3. In order to do this correctly, what you have to do is, I want you guys to write this as well. You would take the denominator and you times it by the whole number. That's what you would do first. Then when you get that answer to this, the product of this, you would then add the numerator. And then you put it over the denominator, the original denominator. So in this case, how I always just do it to remind me, this never changes, guys. So this is always how you change these. So this, you always times, then you add this, and you put it over here. And then with your denominator, it still stays the same. So your denominator is still going to remain a 3. But how you do it again, you do the denominator times the whole number. So 3 times 1 in this case. 3 times 1 is 3. Then you add 2 to it. So 3 plus 2 is 5. So this would now be 5/3. Again, I'll do one more. In this case, again, I'm going to times and plus. So my denominator still remains a 5. What happens is 5 times 4 is 20. Plus your 4 is 24. So the improper fraction of this would be 24/5. So I just think it's so much easier to do this because you will see why. All right, so what they ended up wanting you to know automatically is that 1 foot squares would not work because you have halves, which you can't cut this in a half. It said it did not want to cut anything. So that automatically is not going to work. Since there is a half by a half, both of these have halves. So therefore that is going to work. So therefore having a half by a half would work best. So the question was that they had a 2.5 feet by 3.5 feet. All right, so they are asking for the area. Well, a area of a rectangle of a rectangle is the following formula. In order to find the area of a rectangle, what you have to do is you have to do length times width. So length times width. And that's what we are going to be doing. So here you would do the length and the width. Well, 1 times 1 is 1 square foot, or foot to the 2nd power, because feet times feet is just like in our exponents, like if it was 10, that would be 10 to this times 10 is 10 to the 2nd power. Well, same thing here, but with feet. Since we have feet times feet, it is feet to the 2nd power, which is called squared. So feet squared, or square feet is how they call it. So when you're doing the area, you're always like talking about squared units. So in this case, here's the next one. So in order to find the area of this, you would do length times width. Length times width here would be 1 times 1 is 1, over 2 times 2 is 4. So each one would be 1/4 of a foot squared, or feet to the 2nd power. Same thing. They still mean the same thing. So it's 1/4 of a square foot. And then if you did this one, it would be 1/4 times 1/4, which would be 1/16 of a square foot. So these are your options. Now, to make your lives easier, guys, I'm going to show you the other way that they wanted you to do this. Again, this is not the way that I would have wanted you to show this, but they wanted you, because they said, okay, you're going to go by halves. Remember that this is a half going this way, and over here, this is going by a half as well, just like how it's showing you. So if we're going this way, we want to go by halves to get to 2.5. So how many halves would that be to get there? So if I kept going, so a half plus 1 more half, that would be 1 whole. But we need to get to 2.5. So you keep on going. So this would be another half and another half. Oh, this is 1 whole as well. So far we got 1 whole plus another whole. So now we got 2 wholes, but we need to get to our half now. So that would mean we need 1 more space. So this is how long it would be here. Now this way, they wanted us to get to 3.5. So going by halves, we now need to go to 3.5. So I'm going to turn this here. A half plus a half. Okay, there's 1 whole. And then a half plus a half. Here's another whole. But remember, we need to get to 3.5. So we're not quite there. A half plus a half. Here is another whole. So far we got 1, 2, 3 holes. And now we got to get to a half, which is all we have left. So in order to do this, my rectangle would look like this. And then they wanted you to say, okay, what is, how many squares cover up this entire diagram? So they wanted you to count every single one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So they would say, how many are covering this entire thing? It's actually 35 squares. And how do you know? Well, you got a 7 by 5. So a 7 by 5 is your rectangle. So therefore that would be 35 squares, but they wanted you to find the area of just one tile. Well, our one tile, we already figured out. The area of one tile is a half times a half, because length times width of just this would be 1/4 square foot. All right, so that is just the tile of 1. So then in order to do this, they said what you could do is you could then just multiply, since 1 square is represented in the area as 1/4 of a square foot. So this is actually 1/4 of a square foot if you multiply these two. So therefore they're saying, well, since you know what 1 square is, how many squares are there total here? Well, we already said that they came out to be 35 squares. So what they're saying is you could do 1/4 of 35. 1/4 of 35 would be 35 over 4. Which you can't have as an answer. So then they want you to go ahead and divide it. So how many 4s go into 3? You can't. How many 4s go into 35? Would be 7. Nope, 8. Sorry, 8. Just one more time. 8 times 4 is 32. That would be 3 remaining. So therefore my answer would be 8 whole times and then 3/4 of a square feet. So that is my actual answer to this entire problem. Now I think that this takes a long time. Now, I am going to show you the quicker of the two ways. I think it would have been personally a lot easier to do another way. And I am going to show you that right now, but I'm going to do it on the other page. So on this page, remember it was 2.5 times 3.5. Now, like I said, and I'm going to show you in just a minute why this is so tricky to do it as itself. There's a lot of steps to it if you want to do it like this. But my advice to you is to change these to improper fractions. So that is what I'm going to tell you to do. So if you were to do this, remember to change it to improper fractions. You times and then you add, you times and then you add. So remember it's 2 times 2, which is 4 plus 1. So 4 plus 1 is 5 is my numerator, and then my denominator still stays the same. Here, my denominator still stays the same. How do I change it? Is 2 times 3 is 6, plus my 1 is 7. And now I go ahead and just multiply across. If you multiply across, 5 times 7 is 35 over 2 times 2, which is 4. And of course, you can't have that again. So how many 4s go into 35? Well, 4 goes into 35 8 times. That would be 32. So when you subtract, that would be 3 remaining. So my answer would have been 8 wholes and 3/4. And then this is square feet again. Now, when they are talking about you like making up the things, I think it's a lot easier if you see this because it's telling you you want 5 1/2s. And then here, this is like saying 7 halves. So in this case, you would be like, this is truly showing you 1/2 plus 1/2 plus 1/2 plus 1/2, and then one more 1/2. So in this case, what you would have done is right here, that's exactly what it's showing. This is showing 1 plus 1 plus 1 plus 1 plus 1, and that is showing 5 halves. So you could just do it that way. And then on this side, it is showing 7 halves. So then this would be just doing 7 of those. And then just multiplying 7 halves. And then that's all you would have had to do. So we'll do more of these. I'm just kind of showing you, you would have just have done a lot less work with just changing them. And you're still getting the exact same answer. Now, when it comes back to doing this the normal way, to multiply mixed numbers, a lot of people think, oh, this is so easy. All I got to do is do 1 times 2 and then 3/5 times 3/4. And that is very, very wrong. So I'm going to say, don't do this. This is what a lot of people do. So if it was like, for example, they're 1 3/5 times 2 3/4, a lot of people think it is so easy because you just have to times 1 times 2, which is 2, and then multiply these, and then that would be 9/20. And then they're like, that's it. No, not true. If you want to go about using multiplication of mixed numbers, you can do it, but I'm going to show you the proper way that you would do to solve this. And it is not that easy. So I don't want you to use it this way. If you wanted to do it, what you would have to do is you would have to rewrite it. What they wanted you to do is separate out the 1 3/5. So 1 3/5 is really 1 plus 3/5. And then 2 3/4 is truly 2 plus 3/4. And then what they wanted you to do is make an array out of it. A rectangle out of that. So I'm going to do a big rectangle. And then go ahead and you're going to do length, like a length times width. Well, here's the thing. The width would have been 2 plus 3/4 when we separate it out like this. And then this one would be 1 3/5. Okay, so then what you have to do next is you have to then multiply each of these. So what is 2 times 1 is 2. Then you would do 2 times 3/5, which comes out to be 6/5. We'll keep it like that right now, and then we'll change it up later. So far it's 6/5. And then here, what is 3/4 times 1 would be 3/4. And then here, what would be 3/5 times 3/4. Well, this one would be 9/20. So then once you have your answers to these, then you have to add all of these up, and then you would get your answer. So now I'm going to have to add all these up. This would be 2 wholes. Then I would have 6/5, and then 3/4, and then 9/20. Now I would have to add up all of these. Now, can I add up these fractions as they are? You should be telling me absolutely not, because they are all um, different denominators. So the one thing I could do is look at the bigger one. Can I get everything else that is smaller up to the bigger one, which is 20? And I most certainly can. So what I'm going to do is I'm going to bring my whole 2 over. There was nothing wrong with that. Now, how would I change a 5 to 20? I would times it by 4, and I would times the top by 4. So that would be 20, oh, sorry, times the top by 4 as well. So that would be 24/20. I got ahead of myself. What would I do to a 4 to get it to 20? I would times it by 5. So then I would times the top by 5. So 5 times 3 is 15/20. And then here, this is already in 20th, so I'm just going to bring it down as well. So here, my whole number is still just a 2, but then I got a big number. So I got to add up all of these numbers. So I'm going to do that over here so I don't confuse myself. So this comes out to be, let's see, 24, 15, and 9. So what is 9 plus 9 is 18, carry your 1. And then 2 plus 1 plus 1 is 4. So that is really saying 48/20. So can I have this as an answer? And the answer is no. So you got to go and separate the two. So I'm going to figure out what 48/20 is. So 20 can go into 48 2 times. That would be 40 with 8 remaining. So my answer to this would be 2 and 8/20. But then don't forget about my previous 2 wholes. So that would be 4 and 8/20 would be my answer to that. Then again, it could be reduced down. What can go into all of these would be, to reduce this down, you could put in a 4 into both of these. So then that would be 4, and how many 4s go into 8 would be 2, and how many 4s go into 20? That would be 5. So you could have also had 4 and 2/5 as well as an answer to this. So this is if you just want to do your normal multiplication, if you really like that. But the only thing is, you cannot do it like this. It is not that easy, guys. You literally have to do it out like this every time. So that is why this is too much work. I would much rather choose to do this when I just change them to improper fractions and then just go across and then just only do this one time. So I am going to tell you, when it comes to multiplying mixed numbers, to save a lot of time for yourselves, just change them automatically to improper fractions and then multiply. So we're going to be doing that way here. So they said use the grid to find the area. Let each square represent 1/3 meter by 1/3 meter. So they're telling you here's the 1/3. They wanted you to do 1/3 plus 1/3 until you got to 1 2/3. And then here they wanted you to do the same thing, going by 1/3, going down this way. To save time, I will tell you what to do. Just multiply these. And like I said, the quick way is to change them to improper fractions. So again, times and plus, times and plus. So this is 3 times 1 is 3, plus 2 is 5, over, keep your denominator, which is 3. Then you're going to times it by the other one. 3 times 1 is 3, plus 1 is 4 over 3. So right now, guys, the other reason why I like this is already telling you how many thirds you need. So it is, remember, this was each one of these were 1/3. So this is a 1/3 by 1/3. So they're already telling you what you need is you need 5/3 for a length. So I'm going to do that. 1, here's 2. This is 3/3, 4, and 5/3. So this is going to be how big? Now this one is 4/3. So that means 4 of these. There's 1/3, 2/3, 3/3, 4/3, and then I can make my rectangle out of that. So this is going to be my rectangle right here. Now all I just got to do is go ahead and solve it. What is 5 times 4 is 20 over 3 times 3, which is 9. And can we have that as an answer? No, we cannot. So we have to do how many 9s go into 20? That would be 2. 2 times 9 is 18. Subtract, that would be, can you have 0 and take away 2? You cannot. So you have to subtract, that would be 2 remaining. So therefore my mixed number here would be a big 2 and 2/9 square meters. All right, but what they wanted you to be able to do is say, okay, 1 and 2/3, I keep going by thirds until I get there. They wanted you to already know how to do that. And keep going by thirds until you got to 1 and 2/3. And then they wanted you to count and say, okay, that's 20 squares inside because it's a 5x4, which look, we already figured that out already. And then they wanted you to just multiply 1/3 by 1/3, which is 1/9. And say, since each one is 1/9, because you would do 1/3 times 1/3, that would be 1/9. And you have 20 of these to times these. Which, look, we already did it and we already have an answer. So therefore, what is the area of this? It is 2 and 2/9. That's why I would choose to do this way. It is so much faster, so much easier. So here we go. They're telling us right now that the grid is going to be, this, each square is going to be 1/4 by 1/4. Okay, so keep that in mind. Each one of these is going to be 1/4 by 1/4. Okay, so they want you to go by 1/4 until you get to 1 3/4. And then this side, you could do the same thing. I think it's just so much easier just to change these to improper fractions. So please just change them to improper fractions. It will save so much time. So times and plus. So 4 times 1 is 4, plus 3 is 7/4. Here, 4 times 1 is 4, plus 2 is 4 plus 2 is 6/4. All right, now they want you to make a chart off of this. Well, remember, if each one is a fourth, this one's telling you how many fourths you need to make this rectangle. It's saying you need 7 of those. So this is 1/4. Another one would be 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So that's how long it's going to be. Then this is going to tell you how much down. And it's going to be 6 of these. 1, 2, 3, 4, 5, 6. And then you just connect them to where they meet. And now you just simply just do the math. It can, 7 times 6 is 42 over 16. Can you have that as an answer? Of course not. So you got to see how many 16s will go into 4. It can't, but can it at least one 16 go into 42? And yes, it could. Now, I don't expect you to know your 16, so you would have to do like a guessing and checking. I'm going to guess 2 and see what happens there. That would be 12, carry my 1. That would be 2 plus 1 more is 3. So that is only 10 away. Am I going to be another 16? Can I get another 16 in there? No, I cannot. So then 2 times 16 is 32. Then subtract, that would be 10 remaining. So therefore, my answer to this is 2. So 2 wholes and 10 sixteenths. And then if you wanted to, you could have reduced these by dividing it both by 2, and it would have been 2 and 5/8 square feet. So I'm just showing you, it is just so much easier just to do that. Really, they wanted you to count by fourths until you got to 1 1/3, and then do the same thing over here. Then they wanted you to do 1/4 by 1/4 would be 1/16 for each of these, because 1/4 times 1/4 is 1/16. And then they wanted you to do 1/16 times how many total ones are in here, which is 42 of them. And that is the exact same thing that we're doing. So 42 times 1/16 would be looking like this, and then you would get the same exact answer. So to save a lot of time, just change them to improper fractions. You truly don't even have to worry about writing this out because we're not using that method. All we're just doing is just changing them to improper fractions. So again, in order to find the area of a rectangle, you would do length times width. So here we go. In order to do this, I would change these to improper fractions first. So 4 times 1 is 4, plus 1 is 5 over, keeping the denominator of 4. Here, 2 times 1 is 2, plus 1 is 3 over 2. And now we can just multiply across. 5 times 3 is 15 over 4 times 2, which is 8. And can we keep that as an answer? No, we cannot. So I am going to divide this out. How many 8s go into 15? That would be 1. That would be 8. So 15 minus 8 is 7 remaining. So therefore, my mixed number out of this would be a big 1 whole and then 7/8. So that would be my answer. All right, again, you don't need to use an area model to solve this. Just strictly use the changing this to improper fractions. So you would times and plus, times and plus. So 3 times 1 is 3, plus 1 is 4 over whatever your denominator originally was, which is a 3. Here, if you want to do the denominator first, so you don't forget about that, it's still a 2. So then you do 2 times 2, which is 4, plus 1 is 5. And then you can times. Now, some people would be like, oh, I see that some things can cross cancel. You are right, you could. Or you could just strictly go cross does not matter. It would have been 26. Or you could have cross canceled and changed this to a 2. This would have been a 1. That would have been now 10/3, which again, you cannot have as an answer. So you would divide. How many 3s can go into 10 would be 3. 3 times 3 is 9, and 1 is remaining. So therefore, my answer would be 3 1/3. And then what I want you to do now is I want you to try doing 5 and 6. on your own to multiply this, again, my advice to you is to change them to improper fractions. So please try this on your own. So please pause. Okay, so you should have paused. And if you did, and we tried this all out, you would have changed this to improper fractions. This would have been 11/8. And if you change this one, 2 times 2 plus 1 would be 5/2. You could have gone straight across. It would have been 55/16, which you could not have as an answer, so you should have divided. That would have came out to be 3. Is as close as you could get with 7 remaining. So therefore your answer would have been 3 7/16. Here again, you should have changed them to improper fractions first. This would have been a 9 as a denominator. 9 times 1 is 9, plus 1 is 10 nines here. 3 times 1 is 3, plus 2 is 5/3. And then you just go across. That would have been 50/27, which you could not have as an answer. So how many 27s will go into 50? That would only be 1. And then when you subtracted, that would be 23 remaining. So your answer to this one would have been 1 23/27. And then that is your answer for that. Okay, so next, I want you to next try this one on your own. It says Nancy's garden had a dimensions shown. She needs to find the area of the garden so she knows how the topsoil to buy. She says complete the area model below to find the area. So you could either use the method I showed you, or you could use this type of a method to do it. So go ahead and pause this and try this one on your own. All right, so you should have paused it. If you used my method, which is just changing them to improper fractions to find the area of this, this one would have been in fourths, times, and plus. This would have been 12 plus 3 would be 15. And then this one would have been 8 plus 1 is 9/2. So then you should have gone across and multiplied 15 times 9. That would have been 45, carry your 4. 9 plus 4 is 13. So that would have been 135 over, then go across here. That would have been 4 times 2 is 8, which you could not have. So then you were supposed to divide. Can 8 go into 1? No. Can it go into 13? Yes, one time. That would have been 8. Subtract it. That would have been 5. Check it. We are good. So then you bring down your next one. How many 8s go into 5? It would have been a 6. 6 times 8 is 48. Subtract. You have 5 and take away 8. No, you cannot. So 15 minus 8 is 7. So actually your answer would have been 16 wholes and 7/8. Also, if you use the other option, this would have been your other option. You could have separated out 3 3/4 and 4 1/2. So 3 plus 3/4 and then 4 1/2. And if you did that, that part would have been a 12 for this section, but that's not it. You would have to then multiply these, which could have cross canceled and just have been 3. So that would have been the next one. The next part would have been 3 times 2, which would have been 3/2, which is 1 1/4. Sorry, 1 1/2. And then next, if you went across, it would have been 3/8. So then you had to add up all of this, and then you would have to, so I did it over here, and then came up with a common denominator as well. So when I changed these to common denominators, it would have been 4/8 and then 3/8, so that would have been 7/8. And then here's my holes, which is 16. The other thing that I wanted to talk about would be this one. Tucker's bedroom is a rectangle that measures 3 1/3 yards by 4.5 yards. His dad buys 2 area rugs that each have a length of 4 yards. One rug has an area of 16 square yards and the other one has 12 square yards. Which rug will fit in Tucker's room? And explain. All right, so we have to figure out which one of these is going to fit into his room. So it says he has his bedroom is a rectangle that is 3 1/3 yards by 4.5 yards. So we have to see how big his room is first before we do anything else. So first thing that you should do is you should change these to improper fractions. So this would be 3 times 3 is 9, plus 1 is 10/3. And then this one would be 2 times 4 is 8, plus 1 is 9/2. And yes, we could cross cancel if somebody sees that. 2 can go into 10 5 times. Here, a 3 can go into 9 3 times. So then if you go crossed, 5 times 3 is 15 over, and then these become ones. So then that would be 15 square yards. So his bedroom is 15 square yards. So the dad has 2 rugs. One has 16 square yards and the other one is 12 square yards. So which one will fit in his room? Well, the only one that would fit in his room is this 12 square yards because his room is only 15 square yards. 16 square yard rug is too much, is too big. Okay, now we are going to do just a couple over here. Again, I only want you to use changing them to the mixed numbers to improper fractions. So I'm just going to tell you again, first, change mixed numbers to improper fractions. And then show your work, of course. So again, if you need an example on how to do this, if it was like 4 2/3, in order to do this, you would do 3 times 4, then plus your 2 would be 12 plus 2 is 14. So then the top would be 14 and then over the denominator, which is still 3. All right, so then that is what you do. So change them to improper fractions. So keep in mind, and we wrote this down on the other paper. So if you need to do that again, you can help you here. Again, this is just a bit confusing. They wanted you to go by 1/4 until you got to 2 1/4. Then they wanted you to go by 1/4 until you got to 1 1/2. To save yourself a lot of trouble, again, my advice to you was to change these to improper fractions. So this would be a 4 as a denominator. The denominator stays down. 4 times 2 is 8, plus 1 is 9. Times, over here, the denominator is a 2. 2 times 1 is 2, plus 1 is 3. So you should have just gone across. That would have been 27/8. Which could you have that as a um, could you have that as an answer? You cannot. So now I'm going to go ahead and divide it out. How many 8s go into 27? Would be 3. That would have been 24 with 3 remaining. So therefore, you are still getting the exact same answer of 3 3/8, just an easier way. So I would suggest you do this way. I'm again just going to do this one with you. Again, they're telling you each one is worth a third, and this is another 1/3. So my advice to you, even if you were to draw this, I'm going to draw this one with you. But even if you are to draw this, just changing them to improper fractions is going to help you so much to figure out how many thirds that they are. So remember, the denominators are the same. So then you go 3 times 1, which is 3, plus 2 is 5. 3 times 2 is 6, plus 1 is 7. So then when you multiply this, this would be 35/9. And so what this is doing is it's telling you you need to make one that has 7 thirds. So remember, each one of these are 1/3. So to do 7 of them, you keep doing 7. So that's 2, here's 3, 4, 5 thirds, 6 thirds, 7 thirds. And then this one would be the other one, which is 5 thirds. So do 5 of them. 1/3, 2, 3, 4, 5. And then go ahead and make up your rectangle. So that's how you make a rectangle based off of this. Then, of course, you cannot keep that as an answer. Again, on your homework tonight, you won't be needing to make a rectangle. I'm just showing you that this basically is helping you tell you how many squares you need to make this way anyway. How many 9s go into 35? And the closest that you could get is 3. That would be 27. Can you have 5 and take away 7? No, you cannot. So then 15 minus 7 would be 8. So therefore, your mixed number out of this would be 3 wholes, and your fraction would be 8/9. So 3 and 8/9. All right. So on your homework, again, just use the changing of mixed numbers to improper fractions to help you solve that. You will do 3 and 4. I will do 5 with you. Again, my advice is to just change these. So remember, length times width. So here's your length and your width. So in order to do this, change them to improper fractions. So the 4 remains a 4 over here. It will be a 2. So then go ahead and do times and plus. So 4 times 3 is 12 plus 3. So that would be 12 plus 3 is 15. And then over here, times and plus. So that would be 2 times 2 is 4 plus 1 is 5. So in this case, this is going to be our answer. So now all you do is you just go straight across. 15 times 5. That would be 25, carry your 2. 5 times 1 is 5, plus 2 is 7. So it would be 75 over, go across here, which is 4 times 2 is 8. And can we have that as an answer? Of course not. So I'm going to divide. How many 8s can go in as close to 75 as possible? It would be 9. 9 times 8 is 72. Subtract, that would be 3 remaining. So then your answer would be 9 wholes, and the fraction part would be 3/8. 3/8. And that is your answer for that one. All right. You are going to have 6 for homework. You can cross out number 8. You're not doing that. but we are going to do this one together. A painting is 2 2/3 feet long and 1.5 feet high. What is the area of the painting? Again, area means length times width. So here are your height and how wide it is. So it does not matter what order you put them in. So I'm going to do 2 2/3 times 1.5. And then go ahead and change these to improper fractions, times and plus, times and plus. So 3 times 2 is 6, plus 2 is 8/3, and this one would be 2 times 1 is 2, plus 1 is 3. And can anything cross cancel? It sure can. A 3 can go into 3 one time, so they both cancel out to be 1s, because that is 3/3 is 1 whole, so that would be 1/1. Here, can a 2 go into 8 evenly? Yes, it could. How many 2s go into 8? That would be 4, and this would be a 1. The answer would be 4 times 1 is 4 over 1 times 1, which is 1, which is 4 square feet. Now, if you did not like that method, you could have just as simply gone across and did the same thing. If you did across, that'd be 8 times 3 is 24 over 3 times 2, which is 6, which how many 6s go into 24? It's still going to give you a 4. It does not matter which way you did it. But then you have to say square, because area is always squared. Square, and then you talk about what it was talking about, which is feet, square feet. So that would have been your answer to both. Either way you use it. Okay, so that is that. Here on the back, you will have 1, 3, 4, 5, and 6. Oh, wait, not 5. Cross out 5. So 1, 3, 4, 6, and then I'm going to do 2 with you, one last one. So it says Bill's living room floor is covered with carpet tiles. Each tile is 1.5 feet long by 2 3/5 feet wide. What is the area of just one tile? So remember, this is telling you your tile. So in order to find area of it, you would do length times width. It does not matter which numbers you go in first because we are timesing. So I'm going to do 2 3/5 times 1.5. Again, my advice to you when it comes to multiplying mixed numbers, just change them to improper fractions. So that would be a 5 as the denominator, times and plus. So 5 times 2 is 10, plus 3 is 13 times. And then over here, the denominator would still be a 2. 2 times 1 plus 1 is 3/2. So then you just go across. 13 times 3. 3 times 3 is 9. And then this would be 3. So that would be 39 over 5 times 2 is 10. And can we have that as an answer? No, we cannot. So how many 10s can go into 39? That would be 3. When you subtract, that would be 9 remaining. So therefore, my answer would be a big 3, and then my fraction would be 9/10 of square feet. And that is your answer. All right, and that is it for this lesson for 7-7. I will see you guys on the next one. Bye.